For the comprehensive exercise, our team decided to do a calendar program. For the description of the project, we're doing a 12-month planning calendar, and each month is displayed showing a number of events, as well as the specific dates that go with those events.
What are some of our requirements? The system will allow the user to input a year, and in return, the system will print out a calendar that matches the year. The system shall display all 12 months, and the system will be prompted for any events that will be added in. And for that, the specific dates for the events will have to be prompted, and the actual name of the events. The users then shall be able to add the events into the system, and the system stores it in a text file outside of the program. This allows the program to take in information when it stops running and it is run again. The system shall be able to output the updated calendar so users can see an overview of events inputted from before.
So for our design, we had two designs, and here are some pros and cons of it. For design one, our pro is that each class is detailed and each attribute aligns with what we expect to cover in the class. The con is that we're not sure where the description for the event is covered, and some of the attributes in the classes are repeated. For design two, our pros are that the input is consolidated in event class, and the month and days are built well and are specific. The con is that it's not clear where the updated calendar is displayed. And for our team, we decided to choose design one and sort of cover the cons as we were doing the implementation of the program.
So here's a quick demo of what our code ended up being and the implementation. So on the left is the first calendar that you're supposed to print, which contains just all of the months and days without any of the events. And then on the right is an example of the kind of in between where it asks the user for event if they want to add events, and then we'll print the second calendar out, as you can kind of see the start of that with the annotated events. And one slight issue that we ran into with the implementation was just organizing the events to where they should be, and also getting the correct months on the kind of day of the week where they should be. So like the start of the month, is it on a Wednesday, a Thursday, whatever? And then here is a specific example of some of the error checking that we had to do as well. This is for the input of the year. Our bounds for the year, even though we theoretically could have done any year, we're supposed to do 2021 to 2030. So if the user enters a year outside of that range, then the program will just reprompt until they enter a correct year. And then down below is another bit of error checking that we had to do for getting the proper kind of input format from the user. The events had to be formatted in the month and then date and then a string description. So if you had, for example, in the bottom picture a wrong date, then the program would throw an exception. And then here is on the top an example of printing out the annotated events below a month. So for here we have January. And if you have multiple events on the same day, we would have to print them in a bulleted list format, as you can see on January 6th. And then on the bottom is just another example of error checking that we ended up having to do, where if the user entered a month that isn't actually a month, then it'll throw an exception.
Okay, Okay, for system testing and unit testing, basically we tested the range of the year validity of the date month, such as 2021 and 2030 are equivalence class of year. Any date that is out of the bound the month, and if the year is a leap year, that will be the boundary values. And also the months that are out of the bound of 1 to 12. We also tested the display of multiple events in a day. And we tested the case that if there are too many inputs for once. For this project, we have more chances to practice the use of implementing multiple classes and learn how to connect each of those. We realized that there are quite a big gap between what we have designed and planned for the program at the beginning and what we actually ended up with in our program. And so this emphasizes the importance of keeping a documentation on our progression of the code and keeping track of our thought process within a program by leaving comments. And finally, we learned how to use Zeller's algorithm to calculate the start date of a month to make a consistent calendar. And that's our presentation for calendar program.